Isaac Newton, born in 1643, was a curious child. From a very young age, he exhibited a keen interest in understanding the world around him. He loved to tinker and build things, often spending hours creating intricate structures and devices. He was fascinated by the world around him, always asking questions and seeking answers. He wanted to know how things worked, whether it was a simple toy or a complex mechanism. Newton was born in England, in a small rural village. His family lived on a farm, surrounded by nature and the simplicity of rural life. He spent his days exploring the fields and streams, observing the plants, animals, and the changing seasons. He observed nature closely. These observations sparked his curiosity and fueled his desire to learn more. Even as a young boy, Newton showed a knack for problem solving, often coming up with creative solutions to everyday problems. He built sundials to tell time, demonstrating his early understanding of the principles of science and engineering. He constructed a working model of a windmill near his home, showcasing his ingenuity and technical skills. His inquisitive nature, combined with his early experiments, hinted at the genius he would later reveal to the world. These early experiences laid the foundation for his future discoveries and contributions to science. Newton's family recognized his intelligence. They sent him to school. He excelled in his studies. He loved to read and learn. He was especially interested in mathematics and astronomy. At school, Newton was a quiet but brilliant student. He devoured books on mathematics, astronomy, and philosophy. He filled his notebooks with diagrams, calculations, and ideas. He wasn't just reading, though. He was conducting his own experiments and forming his own theories. He questioned everything, always seeking deeper understanding. Newton's insatiable thirst for knowledge laid the foundation for his groundbreaking discoveries in the years to come. One day, Newton saw an apple fall from a tree. This seemingly ordinary event sparked a series of profound thoughts in his mind. This simple event made him think. He began to ponder the mysteries of nature and the forces at play. He wondered why the apple fell down instead of sideways or up. What was the invisible force guiding its path? This led him to his theory of gravity. It was a groundbreaking realization that would change the course of science. Newton realized that there must be a force pulling the apple towards the earth. This force was not just a random occurrence. He called this force gravity. It was a universal force that acted on all objects. He theorized that this same force kept the moon in orbit around the earth. The moon's path was not random, but governed by gravity. This was a revolutionary idea. It connected the motion of celestial bodies with everyday objects. Newton showed that the same force governs both the apple falling to the ground and the moon orbiting the Earth. This was the essence of his theory of universal gravitation. His discovery of universal gravitation was a giant leap forward in our understanding of the universe. It laid the foundation for modern physics and astronomy, forever changing how we perceive the cosmos. Section 4. Laws of Motion. Unraveling the secrets of movement. Newton didn't stop there. He was a pioneer in understanding how and why objects move the way they do. He also developed 3 laws of motion, which are fundamental principles that describe the relationship between a body and the forces acting upon it. These laws explain how objects move and interact with each other, forming the basis for classical mechanics. His first law, often called the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion at the same speed and in the same direction unless acted upon by an unbalanced force. This explains why a book on a table remains still until someone moves it. His second law, which is perhaps the most famous, explains how force, mass, and acceleration are related. It provides a quantitative description of the changes that a force can produce on the motion of a body. It states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. In simple terms, the harder you push, the faster it goes, but heavier objects require more force to move. The third law is equally fascinating. It states that for every action, there is an equal and opposite reaction. This principle is why rockets can launch into space. This means that when you push on an object, the object pushes back on you with an equal force. These three laws together form the foundation of much of our understanding of physics and engineering. Section 5. Adventures in Light. Newton's experiments with optics. Newton was also fascinated by light. He conducted experiments with prisms. He discovered that white light is actually a mixture of all the colors of the rainbow. He found that when light passes through a prism, it bends. Different colors of light bend at different angles, separating white light into its colorful components. This discovery revolutionized our understanding of light and color. It led to the development of new technologies like the reflecting telescope. Newton's work in optics demonstrated his meticulous observation skills and his ability to challenge existing scientific ideas. Section 6. The Legacy of a Genius, Newton's Enduring Impact. Isaac Newton's discoveries changed the world. His laws of motion and gravity are still used today by scientists and engineers. His work laid the foundation for modern physics. His work influenced the development of mathematics, engineering, and astronomy. His ideas helped us understand the universe in a whole new way. Newton's legacy extends beyond his scientific contributions. He inspired generations of scientists and thinkers. He showed us the power of observation, curiosity, and the relentless pursuit of knowledge. Section 7. Newton's world today, from smartphones to space travel. We see Newton's influence all around us today. His laws are used to design cars, airplanes, and rockets. They are even used in computer animation and video games. Every time you use your smartphone, you are benefiting from Newton's work. The GPS technology in your phone relies on his laws of motion and gravity to pinpoint your location. Newton's work wasn't just about understanding the world, it was about using that understanding to create new possibilities. His legacy reminds us that science has the power to transform our lives and shape our future.